I'm off to Nicaragua to Masaya volcano, and I just need to pack my bags ready to do that. So the first thing I'm going to do is to pack up a bag of these. These are survey nails. What we do is we bang those down into the rock so that we can mark exactly where we need to make our measurements. And what we measure is gravity using this gravity meter. Gravity is important because tiny, tiny changes in the acceleration due to gravity will tell us about how much new magma, that's the molten rock, or gas is building up just beneath the crater. And that's what happens just before an eruption. A gravity meter works on the same sort of principle as market scales. You have a big scale pan, you put some apples in, the spring extends, and the pan goes down like that. Inside here, of course, we don't change the number of apples on the pan. We keep that constant, but the thing that changes is the acceleration due to gravity. The other really important piece of kit, of course, is my backpack, and I put my 100,000 pounds worth of gravity meter very carefully into this, and I'm ready to go. All set then. 5,500 miles, and we arrive in Managua, Nicaragua, on the way to Masaya volcano. Masaya is a basaltic volcano, and as you approach, the thickness of the lava flows increases. The younger flows haven't got many plants growing on them yet, and they're difficult to walk over until they've been broken down through time. Up at the summit is the active crater. It's about 200 metres deep, and at the bottom are small vents just a few metres across through which high-temperature gases come roaring out. The temperatures are so high that when the magma level is high enough, you can often see a red glow at night and sometimes during the day as well. The plume of gas travels from the vent and above the crater, and it can be traced right out over the Pacific Ocean. We're monitoring gravity here to try and work out how much new magma and volcanic gas is accumulating beneath the active crater. The plant, animal, soil and air monitoring are to find out where the major environmental impacts are from this active volcano. The ultimate aims are to learn how and on what timescales changes in the volcano affect the local environment. This research project is funded by the Open University and Earthwatch. Open University students and Earthwatch volunteers work together to help collect the data we need in the field. Without their work, we couldn't do this research because we need to collect so much data over such a long period of time.
My name is Hiroshi Maehara. I'm from Japan.
I'm Michael Perkins. I'm from Edinburgh in Scotland. I'm studying geosciences at the Open University at the moment. I've always wanted to come to Latin America and I love the country here. But the project itself has been great as well. I love working with people who really understand the science here. I think the thing I find most rewarding is being able to go out and make measurements and really contribute to the science effort, to do things that without so many volunteers here, we wouldn't be able to gather as much data. And that for me is the most rewarding thing, to really be able to contribute. It's great to go out into the field and do experiments, and to be able to take your data from something like this and use that to build it into a project or something like that would be amazing. It gives you much more in-depth knowledge of the field, and it inspires you. If you can, go and do an expedition like this, because it's well worthwhile. You see the local culture, you work with real scientists. It's amazing experience, and definitely worth trying.
Now students can study the new Open University BSc in Natural Sciences from almost anywhere in the world, online, and can count Earthwatch volunteering towards their degree.